And I guess maybe
We
that's
are,
just it.
yep, we are now recording. It'll record what's being shared.
Okay, and it will record my voice as well?
Yep.
Great. Okay, so we're here to talk about West today. This is the Zephyr developers multi-tool that we've been working on for a while. The GitHub issue is 6205. We're working towards a 0.2 release this week, at which point we're going to do a wider request for testing. So it is a multi-tool, and it has a massive possible scope, but I'm not going to talk about the many wonderful things that people think that West might do in the future. I'm going to restrict this talk to sort of the primary scope and things that we've got working already, which are building, flashing, debugging, and repository management. So I want to talk about some general tenets and guiding principles. West is for users. It is for all users. So it's on Windows and Mac and Linux. It works the same. It's written in Python 3.4, which is the minimum version supported by Zephyr, and it's Apache licensed just like Zephyr. That said, the user focus means that internal scripts don't belong inside of it, but we do recognize that developers are extremely important Zephyr users, and we don't want to make anybody's life harder by introducing it. I do want to be honest that I think the multi-repo adjustment period is going to involve a learning curve just because there are sort of qualitative differences between working in one tree and working in more than one tree. But hopefully we want all the developers to be happy when workflows overlap with West to use West. It is not tied to the Unix philosophy, so that's the 17 things that make Unix what it is, doing one thing well, stitching together orthogonal programs with pipelines, etc. West is a command line tool, but as I said earlier, it does do multiple things, and I hope that it does them well. We are working with an eye towards keeping the code segmented into reusable components and command line tools that wrap them, so that we don't just end up with, you must run West in the background of everything. You can use some of these Python modules independently, but with the 0.2 version number, obviously it's early days. The other thing that we are really focusing on is keeping West optional and making sure that West does not reinvent any wheels. So we want to make sure that it is totally possible to use Zephyr without West. Now, I do want to admit that it will probably be inconvenient to do so in certain situations if you don't have replacements for its features, right? Since we're trying not to reinvent the wheel, we're providing features that we can't find adequate solutions for elsewhere, so it is actually trying to serve a purpose. But lest anybody get worried, it's not build.sh. The build commands use CMake. It's not a build system. It knows how to use Zephyr's build system. And similarly, the repository management just uses Git in a multi-repo context. It's not a version control system. We're not going to do anything crazy like try to write our own. That said, there's kind of an asterisk on optional. If you're using Zephyr's build system targets to flash and debug, you're already using West. We have a copy of West inside of Zephyr. And so some of those convenient features are actually already part of West. Okay, so let's see, next slide. Let's talk about building, then I'll do flashing and debugging, and then I will do the repository management. So I think in a single sentence, the problem statement that we're trying to address with having some sort of build supporting West is that the Zephyr build system is great, but sometimes it can be a bit hard to get started with, especially for beginners, and especially in certain environments. Now, I'm a Linux user, so I'm fine with environment variables, but I've heard that they can be hard in certain cases and interrupt people's workflows. I do think that the use of raw CMake can lead to somewhat repetitious command line invocations to set up build systems, especially if you're developing in a bunch of different applications. And this is actually one use case in which this is more helpful for the West developer than perhaps just the West user that might only be caring about one application. I think just the structure of using CMake can make it hard to produce tiny little error messages when one thing goes wrong, because there's a bunch of other unrelated output as the build system starts to bootstrap itself. Then it discovers something goes wrong and blats out an error. And then there's just sorts of minor irritations. My pet peeve is having to change directories between the source and the build directory all the time. I do find that there's little things like that that chafe, that make it nice to have a separate tool. So I didn't time my presentation, so I'm gonna switch to the demo. But if it starts to seem like I'm running out of time, I might cut some of the later demos in favor of getting through the slides. But let me switch to a new share. So right here, I have on the left kind of a plain vanilla Zephyr, which was installed, without West, and we're going to not use West as much as we can. And then on the right over here, I have a tree that I've set up with West. So let's start on the left. So I'm going to assume that we want to build the Hello World application. I'm going to assume that we have read the documentation, pretty big assumption, and set up the toolchain and installed the SDK. So we're already doing pretty well. Let's go into the Hello World directory. And we know something about CMake, so we know we have to make a build directory and change into it. All right, now let's make the sample. Oh, that didn't work. And this is kind of a famous error message within Zephyr at this point. It doesn't say so, and it's kind of unguessable why, but the real problem here is that there's no Zephyr base environment variable defined. And people ask about this, and there's just not a really good way to solve this problem and make the error discoverable. So of course, we're all Zephyr developers, so we know that we have to go all the way to the top directory, and then we have to source the zephyrm.sh script or zephyrm.cmd on Windows, and then we have to go back, and now we can build it, right? Okay, not really. So I do have a bunch of different lines of output, something about finding Python, something about a log at the bottom, and then kind of in the middle here, there's the real error, which is that I didn't define board. Okay, so I'm going to go read the documentation. I'm going to figure out that I have a favorite board, and it's supported by Zephyr, which is awesome because we have so many boards. And I'm going to use the NRF52 Blue Nano 2 because I use that all the time. Now I can make it, right? Oops. Well, so it turns out that because of all the previous CMake invocations where I was trying to figure out what was going wrong, I've sort of generated a partial and subtly broken build system, which is producing a bunch of these errors. There's actually nothing wrong with the sample or this above command line, but because it's dealing with a dirty CMake tree, it's busted. And so let's kind of prove that point. Oops, it didn't work. Okay, so at this point, I'm probably going to go ask for support. And really, all that I should have done in the first place was just clear out my entire build tree. And now I can set it up again. Okay, so this actually does produce a working build system. However, unfortunately, the default on CMake on my operating system is to generate makefiles, which is not what Zephyr recommends, right? We kind of prefer that everybody uses Ninja for various reasons. But it does work. I can generate a massive amount of make output and see that, okay, somewhere there's a Zephyr.elf and there's a kernel elf. All right, like I'm going to look for those. Nope, they're not anywhere here. Maybe I'm going to run a find command and I'm going to see where they are. Okay, it's in the Zephyr subdirectory. Like, okay, so there's reasons, this nasty output and this kind of buried, where's the actual final build product that happens in the makefile output. And so let's blow this away and try it again. So I've made the pristine target, which just nukes everything. Okay, now I'm going to try it again. I'm going to use Ninja this time because, I found that other thing in the documentation. Great. Now I've got this awesome Ninja build system. And I'm going to run Ninja. So that's all I have to do. Great. And it produced the final executable. So, ultimately, it wasn't that many steps, and this was the CMake line that I needed to run. But it's, especially for a first-time person, and, I'll be totally honest, I'll forget something every once in a while, and then I'll mess something up, and then it's just a little bit of extra friction that we sort of, as the people that are working on West, think is not really necessary. So let's try it again, over here on the right. Now, just to show you what's in here, there's a West directory and a Zephyr directory. And I've got my toolchain set up, same as I did over there. Now let's go into the Hello World application and run West build. All right, so I did mention that we're at 0.2.0 RC2, so we're not quite done yet. So this warning is something that we're working on. One of the nice things about working with West is that because of the way that it does repository management, it knows where Zephyr is. And so this warning is going to go away. But at least it's telling the user, hey, there's something missing and it's called Zephyr base and it needs to be in the environment. You can also pass it as a command line flag. The other nice thing about this is that it's a quick error that tells you right away that you're missing the board, and that probably this isn't going to work for you. And it will let you run, the build again with force if you really want to, and it produces the same thing and the same garbled, build system that would crash later. So, but assuming that you're not crazy enough to run force after getting a nasty red error, let's nuke that build directory and try again. So I'm going to cheat a little bit at this point and just set Zephyr base. Again, this is going to go away before the final release. I'm sorry, we're not quite done yet. Now we're going to run West build. Oops, that's right, I forgot the board. Let's do it again. We get a little bit of color commentary from West telling us all the things that it did and chose for us. And then it runs Ninja. So that's cool. Now, just to prove to you this is not build.sh, we can just run it again. It uses Ninja. It uses the same settings that it cached before. So we're not doing any of the dependency management ourselves. It has help output, which maybe probably nobody will read, but a bunch of stuff is configurable, including the source West build H. The source in the build directory, the target, so you can do a bunch of stuff, force CMake to run. We don't restrict you in what kind of CMake options you use. You're allowed to pass an arbitrary set of CMake options to your configuration. So it is as flexible as running CMake, but it's just hopefully just a little bit nicer, especially when you're just getting started. So if you want to know how it worked, but because maybe you want to stop using it or whatever, you need to port the build into an environment where West doesn't run, we do have these verbosity flags that you can enable. So this -VVV is turning the verbosity all the way up to 11. So I'm going to rerun that build. And this time you're going to see a few lines like, this is how we ran CMake. This is what got passed internally to the Python subprocess call. This is a command that you can copy and paste with all of the details of how it got run. To both generate the build system and to run CMake in build tool mode to actually run the build. So it'll get out of your way if you want it to, and it really does try not to reinvent or be mandatory. All right, so that's building, and let's switch back to the slides. Flashing and debugging. So, as probably all of us know, Zephyr has the slash and debug server, and actually recently an attached target for dealing with these workflows. And they are awesome abstractions for common cases, but there's always something that somebody needs differently, and everybody has a slightly different use case for how they want to do these things. And the real problem here kind of is a consequence of switching to CMake. Back in the day when we were using kbuild, and make, we could pass runtime arguments to build system targets, make arg equals value and so forth. But in general, CMake build system targets cannot take arguments. This is especially, you could think of this being an issue with something like an IDE build target. And so the only way we can pass, these dynamic values to them is via environment variables, which we've sort of discussed earlier are a no-go. And there are some examples here on the page, but everybody's probably got their favorite reason why the default flash target doesn't quite work for them. So let's see how West attempts to address this. All right, so doing it without, as I said, you really can't right now. You are using West technically. When you run Ninja Flash, you see this line that says using runner prior CD. That's actually emitted by a copy of West that we put into Zephyr. And so I'm not going to spend much more time on that. So I'm just going to switch over here and run West Flash, just so you can see that the unadorned command basically is the exact same thing. I mean, it is actually identically the same. But what else can I do with this? Well, can I get help on that? And obviously that's, that seems like somewhat of an unfair thing. That's actually just the help output for Ninja itself. But I don't think that it's entirely unfair to expect that your flashing tool, your generic flashing tool provided to you by your operating system can tell you sort of generic things that you can do. And that includes things like overriding the board directory, setting up, overriding your kernel elf. These ones are near and dear to my heart because I'm post-processing the kernel binaries all the time to add digital signatures for MCU boot. And you can do a bunch of other stuff, including with a bunch of docs that probably no one will ever read. The other thing that I think is pretty cool about the way that West Flash works is that it can do Flash-specific introspection of the CMake cache, which is where we store all these variables. So, again, it really tries to get out of your way if you really, really don't want to do it. So all this information that's needed by West to flash the target is stored in the CMake cache. And you can ask for context on the current build. And it'll tell you stuff about, all the different ways that Zephyr can flash things. It'll also tell you very specific options that you can pass to West Flash for the particular backend, which happens to be PyOCD, that you're running in this build system. And it'll tell you, in cases where the board supports multiple ones, it'll tell you the default one, and there will be a list of ones that are available here. You can pick between them at runtime by passing a flag. It's pretty flexible. So that's why I think it's nice and worth having. And debugging is similar enough that I'm not going to bore you with a separate demo. So I'll just go back to the slides. Please stop me at any time, by the way, if you want to know more or have a question.
Maybe a word about further. You mentioned MCU boot and how overriding the default Flash kernel image allows you to reuse the same infrastructure, but with a particular one that you have post-processed. But beyond that, we also can contemplate in the future closer integration with bootloaders, meaning that even at the West build or at the West Flash stages, one can actually add a command or extend the Flash or the build command so that they actually integrate with some of the most well-known bootloaders, right?
Yeah, absolutely. And Founders.io's Zephyr-based product does exactly this, and it's written in Python. Essentially because we felt like it was a little bit too complicated to get this done in a generic enough way. A lot of the MCU boot related documentation you'll see is like, okay, now you have to sign the image, and then you're going to have to dig around in the device tree for all these magic values. But it is possible to make it pretty generic and cross architecture and do that both in the building and signing and flashing. So we have an existence proof of that, and part of the reason that I'm involved in this is because we want to be upstreaming that. So yeah, thank you for that, Carlos.
Sure.
Okay, so let's talk about repository management. The big problem here is that Zephyr is kind of vendoring a bunch of its dependencies into the mainline Git repository. If we need embed TLS, we make a copy and we put it in the Git repository. If we need TinyCrypt, we make a copy and we put it in the Git repository. That will never cover all of the cases, and so it kind of privileges the use cases that maintainers and developers are concerned with, which I think is a problem. But just in general, it has a bunch of other issues. It's not a good idea. I've kind of made the list of issues in decreasing size by sort of rough consensus order of priority. And one of the biggest ones is license and IP restrictions, right? As members of the TSC, we've had to do several votes on whether or not to accept this particular external code or not, depending on its license. Sometimes things have gotten rejected because of the license, et cetera. This can, cause headaches for compliance. If your legal department says, well, there's a bunch of GPL code in there, and you say, no, it's unused, but now you have to prove it. If it's not in the tree, then it's not compiled, right? Just sort of period. There's also issues like, it makes it harder for users to use their own versions, right? Like, we have some build system glue for setting up an external embed TLS and stuff like that. And, we kind of have to special case this every time we do that. And there's a bunch of other things. Like I think one interesting example that we already have is the NetTools repository, right? So there's a bunch of host tools that are really convenient for doing Zephyr networking development, and they're in an external repository, and that makes perfect sense. But they're not pulled down, and so users have to kind of clone them manually and stitch them together if they want to use them. So there's consensus that we want to go multi-repo, and then the problem really just remains how. Is that pretty clear? Any questions on that? Okay.
Matti, just at one point, which is for companies or users that want to integrate or swap out. I think it's one of your points that maybe it wasn't made strong enough. Is that either swap out or augment Zephyr, having a tool that actually allows them to do that side by side and in a way where you can, because extending kconfig, extending device tree, extending CMake is often not enough. We need to make also Zephyr aware of potential external projects, so and allow them to coordinate with each other, to build together, and also to be fetched from multiple repositories together. And that's important, I think, in the future also when we want to add binary blob support to Zephyr. So right now there's already mentions of that, and I'm sure there will be more and more. And we won't have binary blobs obviously in the repo, but we want those to be known by Zephyr, and we want those to be buildable by CI and in regression tests. So that's also additions that companies make, proprietary additions to the Zephyr open source code base.
Yep. Okay. Yeah. Thank you very much. Those are excellent points. Okay.
So,
go ahead.
Yeah. I mean, is the multi-repository support in West right now? I mean,
yes, it is. It is, and I will show you a demo. If it's okay with you, I'd like to kind of drag us a little bit through the history, just so that we can see why we went the way that we did.
Yeah, drag away.
Okay, cool. So repository management is hard, so we went shopping for existent solutions, and we ran into Repo from Google, which is Android and AOSP's multi-repo tool. There's Depot tools, which is how Chrome is built. Obviously, Git has submodules. CMake has some stuff. We looked at what it would look like to do it all by hand. We looked at the repository.yaml files provided by the Minute operating system, and then, kind of last of all, we thought about doing it ourselves. And then there's a link in that presentation about baking off a final 4. So we picked 4 of these and kind of evaluated a little bit more clearly what it would take to bring them into Zephyr. And they all had some significant enough showstoppers that we are going to roll our own, and we are rolling our own. It's not our first choice, but I'd be happy to deep dive into the reasons why none of the other ones were deemed sufficient, probably offline. Feel free to ping me, just because it's kind of a big spreadsheet in that link. We do have a fair bit of experience with Repo on the team, and we're trying to draw as much inspiration from it as we can. I think it's the example of existing code out there that does the same thing that fits the Zephyr use case the most closely, right? Because obviously Android is a giant license-sensitive, complex, includes binary blobs, cross-development embedded system, and so it fits the bill quite naturally. It has some problems, and we're trying not to use any of the XML. So here's a really quick oversimplification of how Google Repo works in case you've never touched it. There is one kind of repository that rules them all, and Repo only knows about Git, by the way, and it's called the manifest repository. And this is a manifest kind of in the shipping terminology, where it's like a bill of goods, right? It contains an XML file, which is the manifest file, and then the manifest file contains these project elements, and each one of those is a textual description of attributes of another Git repository that is kind of being referenced by this manifest. Then there's a client, which is called Repo, that can manage a local installation of both itself and the manifest repository and all of the projects that it references. So this is kind of pretty much exactly what we need. It has developer workflow. It has a bunch of really interesting features. The manifest XML file format, despite my personal hate of XML, is very flexible. It has a lot of features. So the main problems with Repo, though, are that it's Python 2. It doesn't seem to be making any moves to go to Python 3 in a serious way. It doesn't work on Windows. It makes really, really heavy internal use of symlinks, which is pretty much a showstopper for Zephyr because those require administrative privileges on Windows. It's very tied to Gerrit in terms of its review workflow. So although it does have multi-repo developer workflows, they won't work for us on GitHub. And of course, it's got my favorite markup language ever. So we like the way Repo works, but we don't like the way Repo works, is kind of our conclusion. And we're gonna do something similar, and this is kind of how you set it up. So we've packaged West. We've packaged a piece of West called the Bootstrapper, and we've uploaded that to pip, or the Python package index, so you can install it with pip rather. Because we are working on an RC, which pip will not install for you. If you wanted to try this at home, you would have to give it the actual concrete RC2 version to enable the pre-release. And then what you're going to do is you'll say West init your install directory, and that's going to clone a West manifest, which is like a repo manifest except not. And then it will also clone a copy of West itself. You can then go into the installation directory and then fetch the rest. And I'm running a little bit short on time, but hopefully I've got enough to sort of show you in practice how this works. Okay, so I'm gonna make some fresh shells here. Let me show you what a West manifest looks like. And because I was sort of anticipating network latency, I've played a couple tricks in here to make sure some of these repositories are cloned from my local system. So a West manifest is a YAML file, just like minute repository files, and just like basically all of the other stuff in Zephyr too. So YAML is a very Zephyr native format. There's this manifest tag up top, and then there's kind of these subheaders. There's this remote one in here, there's this defaults one, which is optional, and then there's this projects one. And just to kind of walk through very quickly, the remotes is a list of places where you can get Git repositories from. And every remote has a name and a URL. And the URL is not like a final complete URL. It's actually more of a base URL that's concatenated with project names to produce the final project URL that gets cloned. So I have an Embolivar source directory just so that I can clone things that I've already got on my local file system for speed. And then just to show you how it actually works, I also have one called Zephyr project, which points at the GitHub base for Zephyr. So for brevity, we can do things like specify that the default remote is the one that points at my local file system, and then we're going to have a list of projects. So this is a complete project entry for Zephyr. It will clone from my local file system by concatenating the name of the project with the URL base, which is home Embolivar source, as you can see here. So it means that the Zephyr repository is going to be cloned from here, at least if you're using this manifest. And then just to kind of give you an example of a much smaller repository that's going to be faster to clone, the NetTools repository is under the Zephyr project namespace. So it'll be github.com, Zephyr project, RTOS, NetTools. I'm specifying in my manifest that the clone depth is 1. That's just so that I don't clone the entire history again to avoid a network issue. And we can configure the path, so you can sort of decide where this is going to go in the installation. And so in this case, I'm going to make sure that it's stuck under an extras directory. So that's sort of a whirlwind overview of how the manifest works. And I won't take questions just because I do want to run this code and show you how it plays out in practice. Let me install West. Of course, it's already installed, so that was fast. Go to a temporary directory. Make sure I don't have anything. I don't. All right. Okay. So one of the nice things about West, and actually I think this is a feature that is worth discussing, is that you can tell it where you want to get the manifest from. By default, it's going to pull it off of Zephyr project RTOS /manifest on GitHub. So you can run, West init multi-repo demo, and that's just going to pull mainline. But if you are a Zephyr distributor or a vendor of some kind and you want to provide users your own manifest, you can just ask them please run this one instead, and it's going to initialize a new directory. And let's go inside of it and see what the West version is. So the West Bootstrapper version is the one that I installed from pip earlier, and you can see that it's installed in my local site packages. Now the main West code that contains all the commands is actually in here, and you can see that we've actually merged one commit since RC2, and that's checked out into the tree that West init has created. And the reason why we do that is because it allows us to keep West itself up to date automatically, and this is a trick that we're borrowing from repo. So let's check out what's in here, we have right now just the manifest and the West repositories. And then just for completeness, I'll show you that the contents of the manifest file are the same as what I cloned it from. And let's go ahead and get the projects. So I'm going to run West fetch, and sorry about that Zephyr base. Like I said, we're going to fix it. It's going to clone everything. I'm really glad that I did this on my local file system because I definitely don't have time to fetch the full history off the network. But you can see there's some green stuff from West, and then a variety of other things from the tools that it uses. So now let's see what's inside. We've got the extra Zephyr net tools, which is exactly where we said we were going to put it. We've got the Zephyr tree itself. It just defaults to getting placed in the top level in a directory with the same name as the project itself. We can introspect the list of projects. It'll tell us, kind of where our manifest is, what the projects are, what their status is. And I think I had a little bit more to show, but I guess I'm a little bit running out of time. So I'll just say that, we can West pull, and that's going to help us, keep things up to date. This is actually automatically updating West itself. We can ask it not to do that. I think it's called no update. And it'll just fetch the repositories and not update West. And so, this is kind of the basic fetch workflow. I'm going to conclude with a few open issues and leave this demo behind. The main things that I think are blockers for this to be really widely adopted within the Zephyr project is our continuous integration, the developer pull request workflow, and how we're going to figure out the touch points between CMake and all these external projects that live outside of the Zephyr tree. The main problem with CI is that, testing change sets over multiple repositories and committing them, this is something that has to be done atomically, and that's not something we're set up to do right now, at least in upstream West. Foundries.io does have a way to do this for our product, but it's kind of based on GitLab and our custom CI servers. So we would like to keep talking with with upstream on how we're going to solve this, but I'm not sure that our solution is exactly copy pastable. The developer pull request workflow is kind of related. It's sort of the opposite side of this coin. And then obviously the build system issue here is that it would be easy to make CMake depend on West as a hard dependency to pull out the projects, but we're trying to avoid that, especially given that we've heard people don't always want Git and things like that. So since I'm almost out of time, I won't enumerate the lower priority things, and I think that's it. Thank you for your time.
Thank you, Marty. Any questions?
I assume, just real quick on the manifest and so forth, that there's a way to specify a specific SHA or something.
Yeah, so there's a revision attribute, which is optional and I didn't put in there, and revision can be a head. It can be a branch, a tag, or a SHA.
Okay, cool.
And just to complement that info, you can do that as well for West itself. So if you've deployed your own version of West and you're just using the same bootstrapper as everybody else, during the init phase, not only you can specify the revision and URL for the manifest, but for West itself as well.
And does West also, if you have commits that span multiple repos, do you still have to do those separately, or how do you manage? Does West manage that?
So we do have some support for creating branches of the same names across all the different projects, which is something that's borrowed from repo. But we're, in kind of the spirit of not reinventing the wheel, you commit them with Git in each of the repositories. And then sharing them with others is something that I want to figure out. Yeah, repo has this upload command, which you can, give it kind of the common name for all of these branches, and it'll put them all in the right places on the review servers. And we don't have a good equivalent for that.
Looks like you got questions coming in on the chat.
Sorry, I didn't have that open. Okay. Will I be able to run Git commands? Yes, you will be able to run Git commands.
Yeah, so basically the question was related to like as you showed west pull, which we can use to pull. So instead of west pull, will I be able to use git pull or not? Because it's something like I would be required to remember all the west pull commands possibly, or west related commands otherwise.
No, you can run Git pull. They're Git repositories. They're normal Git repositories. They work the way you would expect. The main reason you want to run West pull is that there's a bunch of different projects which all have to be updated together to versions which will work together, right? If you split things into multiple repositories, and you just pull Zephyr. Now you don't pull some other repository, and the combination breaks, right? Whereas if you use West to pull, it's gonna look at the entire manifest and update everything correctly. So you can keep track of things by hand yourself if you want to, but you don't have to.
Yep, sounds good. Thanks.
So have you guys, so the one project that the other project I'm aware of is the open thread support, right? So right now with open thread, it's down inside the CMake where it pulls the repo, a particular version, I guess, and then puts it in your build environment, the whole source code, and then it goes down and builds that way. It seems like that would be a good one to shift over to West.
Yeah, we've discussed that before. I've never used that particular sample, but I think Carlos is interested in that, if I'm not mistaken.
Yeah, so obviously that what we did, the integration with CMake, an external project that we did for OpenThread, I think was a result of not, in part, a result of not having West.
Yeah,
yet.
I know. That's what I was thinking. I mean, I like the idea of West with the multi-repo and the manifest that you have. So it makes sense that would be a great project to move over to this.
Yeah, exactly. I mean, honestly, the first candidates I think are everything that's in the X folder, because that's just, it's a given. It shouldn't have been there, or it was a shortcut to put it there in the first place. So, but then next we can consider OpenThread. We can consider binary blobs, external binary blobs that today live outside. We can even consider other projects that integrate with Zephyr that are currently just other GitHub repos in the wild. So that if you really want, say, MicroPython or whatever, we don't need to include those. They can be optional. They can be in a branch of the manifest repository. Something not mentioned, I think, by Matisse, that the manifest needs to live in a GitHub repository by default when you initialize. I don't think we have
a Git repository, not a GitHub repository.
Sorry, excuse me. Yeah, a Git repository. Yeah. So that means that you can obviously have forks of that and modifications and branches, etc. So we could provide a set of manifests even.
Would the manifest also exist in the samples?
No.
Because a sample, well, I'm just trying to figure out, I mean, are you going to have to be aware, like say you got an open thread sample you want to create. Mm-hmm. That one is the only one that cares whether or not you have open thread pulled down to your thing. So where does the manifest for your open thread?
That's the dependency that Monty was talking about, how you manage the dependencies between West and the CMake file system. Yeah, because you really need, when you are building a sample that requires OpenThread, which is maintained in a remote repository managed by West, we really need to see if it's available or not. And if it's not, basically tell you that you really need to have this specific Git repo available to us. Yeah. Right now, we just pull it directly. So this is like part of the dependencies. Or if you are building, we are talking about health. If you are building an Intel board that requires something that is maintained in a external repository, you really need to have that. And if we are going to have a sample that depends on OpenThread, OpenThread needs to be part of the default sample or default manifest of Zephyr in this case.
Yeah, and I think what we've discussed is kind of having the mainline manifest be a big giant umbrella that includes everything, so that everything that is upstream in the manifest could build with that same manifest, right? But then, if you want to go be a distributor or start slicing and dicing and removing things, that's kind of at your option.
Oh, okay, that's good. That's a good point, yeah. I mean, I guess I need to play with it too, because I do have a project with a proprietary binary blob that, we will want to take advantage of this, so.
Yeah, so I mean, the idea here is that when you are maintaining boards and SOCs that are not part of the project, Now with out of 3 boards and out of 3 SOCs, you can put those also in a separate repository and have your own manifest, you know, to build and test without exposing this to the open source project. So this opens a lot of possibilities, and I'm excited about all of that. It's just we need to figure out the open points that Marty has just highlighted here. Okay, we are like 7 minutes over time. Any last minute questions? No? Okay, so you can directly ask Marty or come next week if you have any other feedback and put it in the opens. Yeah, but meanwhile you can go and start laying with West, I guess. The presentation link is available in the minutes. And yeah, thank you, Marty, again, and others who worked on that. Carlos, Ulf, and others. Thank you very much.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.
Bye.
Thank you.
Bye, everyone.